For the day, we have the concept called sequence of real numbers, or simply the real sequences. So let us start this topic with an example. The real sequences means you have a sort of a sequence, that is, let's say you have a sequence like 1, 2, 3, 4, 5, and so on. Means what do you have? You have the number 1. Then at the second place you have number 2. At the third place you have number 3. Then 4. Then 5. So basically you are following a pattern in which you are placing your numbers according to the places, right? So this can be written as a sequence of real numbers in the sense that the first place has the number 1, the second place has the number 2, the third place has the number 3, and so on. Another thing, if we have something like 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. So again, you have the collection of the numbers in the manner such that first place is 1 by 1, second place is 1 by 2, third place is 1 by 3, fourth place is 1 by 4, fifth place is 1 by 5, and so on. Means for every value of natural number n, you have a value placed here. Means like here 1 was going to 1 by 1, 2 was going to 1 by 2, 3 was going to 1 by 3. So basically what do you have? You have that each of the values in the natural numbers are going to some values in the real numbers, right? So that's how we define a sequence. Sequence is basically a function from the set of natural numbers to the set of real numbers. That is, you have this as your natural numbers and you have this as your real numbers. So a function which takes natural numbers to the real numbers is generally called by a sequence. So formally defining sequence, sequence is a function whose domain is the set of natural numbers and codomain is the set of real numbers, right? So that's how you define a sequence. So that means you have your answer f of 1 is equal to something, let's call it as x1. F of 2 is equal to something, let's call it as x2. F3 is x3, and so on. F of n will be, let's say, xn, and this chain continues. So whatever values which we have got like x1, x2, x3, and generally xn, these are written in the manner as a set. This collection x1, x2, x3, and so on, xn and continued, this collection or this as a set is called a sequence, right? So for a sequence, what do we have? We have that this is a set. A sequence is a function whose domain is the set of natural numbers and codomain is the set of real numbers, and whatever the this collection, this is the set of all those values, this collection is called the sequence, right? So you have seen as of now that a sequence has the terms like something x, something, let's say n. So this xn is called the term of the sequence, and this n is called the index, right? So what do you have? The subscript n is called the index and xn is called the term of the sequence. Which term? The nth term. That is, it falls at the nth place in the sequence. For example, x1 is the first term, x2 is the second term, and similarly xn is the nth term, right? Where this n is called the index. So this is the definition for a sequence, and let us consider a few examples again. For example, you're given that your sequence looks like this: 1, 1 by 2 again, 1 by 3, 1 by 4, and so on. What does the nth term look like? Agar first term is 1 by 2, sorry, first term is 1, second term is 1 by 2, third term is 1 by 3, fourth term is 1 by 4. What will be the nth term? What is the structure of the nth term?
Ma'am, 1
1
by
by
n.
n.
1 by n means you have that your sequence has the terms looking like 1 by n, where n varies over the natural numbers. So how do we denote a sequence? A sequence is denoted by xn within the angular brackets, or it is denoted by curly brackets sometimes. It is even denoted by round brackets sometimes. The convention which I am going to use will be this one: the sequence within the angular brackets, xn within the angular brackets. So this sequence looks like 1 by n in the angular brackets. If n is equal to 1, you have the value as 1. If n is equal to 2, you have the value as 1 by 2. N is equal to 3, you have the value as 1 by 3, and so on. So this sequence will be denoted by angular brackets में 1 by n, right? So this is an example of a sequence, right? Let us consider one more example. What sort of sequence this will look like? What will be?
2,
Hmm.
4, 6, 8, 10, and so on.
Right? So this is also a sequence because as n varies, you have different values in your real numbers. So this is one of the sequence. Next up, I have another example to show. What will be this? This will be as n equal to 1, you have answer as -1. N equal to
Hmm.
2, the answer is 1.
1.
So this is going to vary in this manner. Means you're always jumping between this is 0, this is -1, this is 1. So you're always jumping between -1, 1, -1, 1, -1, 1. So this is also a sequence, even if the terms are not distinct, but yes, the terms are actually falling into the place as n is varying over the natural numbers. So this is also a sequence. So have you seen what is the sort of the collection of the numbers? There is something which we'll call by range. Range is basically the collection of all those answers which you have got for your sequence. Means as 1 by n was there, so collection of all those answers means the collection of all those numbers which are there with you for whenever n varies over the natural numbers. So the range of a sequence is basically the set of the answers which you have got in simple terms. So for example, you have the sequence 1 by n. So the range of the sequence is going to be 1, 1 by 2, 1 by 3, 1 by 4, and so on, right? And if you have the sequence as 2n, the range you have seen the sequence ka range will be 2, 4, 6, 8, and so on. That's fine. But if you have the sequence as -1 to the power n, the range was just -1 and 1, because what all we are collecting the answers, the distinct answers possible. So only answers possible were -1 and 1, even if the sequence, the terms of the sequence were jumping between -1 and 1, but the answers were precisely overall were -1 and 1. So your range happens to be -1 and 1, but the sequence was -1 1 -1 1 -1 1, right? So that's how you have your sequence, and for that sequence you have some range. Sometimes range is same as the sequence, but sometimes the range is a smaller set than what a sequence would be, right? So that's how we have dealt with what a sequence is. Next, we have bounds over the sequence. Bound over a sequence means we're trying to look for in what manner the sequence, whatever the terms of the sequence are, in what manner they will be bounded. Means you're trying to bound them with some numbers. So bounds of the sequence. So you have a sequence again xn, right? And you want to check whether it is bounded or not. Up. If you have something like you want to check for the sequence is bounded or not, means you want to check ki xn is less than equal to something and is also greater than equal to something or not. Right? These are the bounds. When do we call something to be bounded? When it is less than something and is also greater than something. So this will have to be the upper bound. Have you ever heard about these terms before? Upper bound and the lower bound?
No, ma'am.
So,
No, ma'am.
okay, so we'll discuss this thing first. What is an upper bound or what is a lower bound of a sequence or in general a set? So let's say if you have a set of real numbers, let's say S is a set of real numbers, you call a number M to be an upper bound of the set S if, see, if it is an upper bound means every element of S has to be lying below it. See, if you have an element of S as somewhere here, so this is an upper bound means that acts as an upper bound to all the elements of S. Means none of your elements from S are crossing this number particularly, which is we have called by M. So none of the elements are able to cross the number M. So M acts as an upper bound. Means when do we call M to be an upper bound of a set? If every element is less than equal to that M. If every element of S is less than equal to that particular number M, so this M will be called an upper bound of the set S. And similarly, you can define small m to be the lower bound if, just make a guess. See, if m is the lower bound, means none of the element can go less than that m. Matlab every element of S is lying on the right to the m, means every element of S is here somewhere and it cannot be less than m. Means every element will have to be greater than equal to m. In such a case, this particular number m is called the lower bound of the set S. Right? Got this thing? Repeat.
Yes, ma'am.
I'm repeating it. That m is said to be an upper bound if it acts as a upper cap to every element of the set. Upper bound of a set, right? We are considering upper bound of a set. Means for a set, for every element of that set, let's say S was the set, for every element of that set, we have that each of the element is less than equal to that particular value. So this value will be called an upper bound. And if in case each value is greater than some other value, the value which acts as a lower cap to this is called the lower bound of the set, right? So that's how we define upper and lower bound of a set. For if we have a sequence, now let us discuss upper and lower bound of a sequence. See, if you have a sequence, let's say sort of xn, sequence is also is a collection of numbers, right? x1, x2, x3, x4, and so on. So if we have a collection of numbers, we can talk about its upper and lower bound. If it exists or not, that is different case. But we can at least try looking for some numbers which can act as a upper bound or the lower bound of this sequence as a set. So we call M to be an upper bound of the sequence xn if each of the terms of the sequence, मतलब each of these xn's, जो भी सारे xn's हैं हमारे पास, they'll be less than equal to this particular number n, right? And this should be true for every single n possible, right? Because we want m to be an upper bound of the sequence, means we want that these xn's for each of n, this x1, x2, x3, x4, and every single possibility, like for every single n, this value xn should be less than equal to m. So this should be true for every n in n. So this m is called the upper bound of the sequence xn. And similarly, m is called lower bound of the sequence xn if if m is less than equal to xn for every n in n, right? So for the sequence as well, we have the upper and lower bound. So when do we call a sequence to be bounded? If the lower and the upper bound exist, then the sequence is said to be bounded. So a definition, a sequence, let's say xn, is said to be bounded if there exist the numbers m and m in the real numbers such that xn is bounded above, means xn has a upper bound and xn has a lower bound as well, and this should be true for every n in n. If in case you are able to find these numbers m and m, then xn is said to be bounded. If in case you cannot find any such number, any finite number, such that xn is less than equal to that number or greater than equal to the other number, then the sequence xn is said to be unbounded. So let us consider an example. What about the sequence n? The sequence n looks like n is equal to 1, the answer is 1. N is equal to 2, answer is 2. N is equal to 3, you have 3, and so on. Can you find the upper bound and the lower bound to this sequence? Means you're trying to find one such number such that every term of the sequence is greater than that, and another number such that every term of the sequence is less than that. So what is that? What would be the lower bound of this sequence?
Zero.
0 can be a lower bound, and there can be more than one lower bounds, right? Because every number which is there, like 0, -1, -2, every possible number, every n is going to be greater than 0, then it'll be greater than -1, of course, greater than -2, of course, greater than -3, of course. So you could find at least one number such that the numbers xn's which are n precisely right now, these n's are greater than something. You could find one number. Right now in this case you have 0. I am saying that 1 will also be the case. क्योंकि we have written here less than equal to type structure. So it can start with 1 as well, not a problem. So you have the lower bound. Next up you want to look for the upper bound. Do you have any such number into picture such that this can be, like this can have an upper bound? The question is, do we have any such number for which we can say that n is less than equal to that particular number? No, because no matter whatever number you'll take, there'll be some natural number uske baad. So this is, the upper bound doesn't exist. So this sequence is unbounded, right? And let us consider one more example. Again, the sequence 1 by n, which was of the sort 1, 1 by 2, 1 by 3, 1 by 4, and so on and so forth. So the numbers 1 by n, are they bounded is the question. Means you are trying to look for a number which is less than that and a number which is greater than that. And this should be true for every n in n. So what do you think? Which number can be there which is less than that and the greater one?
मैम अपर बाउंड तो वन हो सकता है मे
बिल्कुल.
बी हाँ वन ही होगा
So you have 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, 7, 8, and somewhere here. It cannot go negative for sure because all the terms are positive. So the terms are going to be approximately 0, but never less than 0, cannot be equal to 0. मतलब 0 से नीचे नहीं जा सकते. Means 0 is the lowest possible value which it can at least go to. I'm not saying which it will be equal to, but at least it can go to, right? And the upper bound is definitely 1 because you are not crossing 1 anywhere. So this sequence, you have two numbers for which 1 by n is greater than that and 1 by n is less than that. So I have got these as the lower and the upper bounds. So this sequence 1 by n is bounded. So that's how you'll check for a bounded sequence or the unbounded sequence, right? So now you'll have to tell me whether this sequence is bounded or not. Is this sequence bounded? What are the terms of the sequence? What are the terms of the sequence? Right? These are the terms. So each of the term is bounded or not. Yes, हमेशा जब भी हम कोई term ले रहे हैं, it is either 1 or it is minus 1. So it is less than equal to 1 and is always greater than equal to minus 1. Moreover, it is less than 2, greater than minus 2. So yes, you could at least find some numbers for which the terms are lying between those numbers. So yes, this sequence is also bounded. Or moreover, you can see using the graph right here, the value is minus 1 or 1 all the time. Means you're not going beyond 1, you're not going beyond minus 1 to the left. So every term is either between 1 and minus 1 or it is precisely 1 and minus 1. So as a sequence, it is bounded because each of the terms are between minus 1 and 1. So this sequence is also bounded, right? So that's how we have talked about the bounded sequences. Okay then. So next up, we are now going to talk of convergence of the sequence. There is some concept called convergence of the sequence. How do we talk about the convergence of a sequence? Let us start with an example yet again. 1 by n is going to be the example which we'll consider many a times. So 1 by n is a sequence and by now you have seen that it is 1, 1 by 2, 1 by 3, 1 by 4 and so on and so forth. So let us try plotting the values. What all are these? So this is 0, this is 1. So the values are 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 6, 7 and you'll see कि at some point of time the values for these 1 by n as n becomes quite large, the values of these 1 by n are very close to 0. Means there'll be a cluster formed around 0, around the point 0. So you can see that this sequence is almost very like the terms of the sequence are very close to 0. Means the sequence is convergent. Means the terms of the sequence are converging towards 0. Converging means they are almost contracting or they are like the terms are getting shrunk to the point 0 or there is a cluster formed around the point 0. So for such a sequence for which we can see that the cluster is being formed around a point is called a convergent sequence. We'll do the formal definition of course, but for the graphical or for the pictorial point of view, How you can see that a sequence is convergent? Whenever you can see that the terms of the sequence are forming a cluster around a point, in such a case we call a sequence to be convergent. So you can see right now that 1 upon n, these terms are forming a cluster around what point? Around the point 0. So such sequence can be seen to be a convergent sequence. So the sequence 1 by n is convergent. We'll do the formal definition that how we really define a sequence to be convergent or not. But yes, as of now, you can see that a sequence is convergent if after a point of time, a cluster is being formed around some point, right? So is the essence of the topic clear? That sequence is said to be convergent if a cluster is being formed around a point, or rather you can find a point where the cluster is formed. In such a case we call the sequence to be convergent, and the point around which the cluster is being formed is called the limit. So limit will be that particular point to which the sequence is converging, or to which around which the cluster is being formed. So such point is called the limit of the sequence, right? Let us just have a look with an example to the one which is not forming a cluster anywhere, then we'll do the formal definition. Let us consider the other sequence n. Means you have 1, 2, 3, 4, 5 and so on. Means your terms are 1, 2, 3, 4, 5, 6 and so on. So are they forming a cluster around anywhere? Are they becoming dense around any point? What do you think? Are the terms getting closer and closer to any point?
No, ma'am.
So
No,
this
ma'am.
sequence is not convergent. So a sequence which is not convergent is called divergent. So this sequence is divergent. Okay. So as of now you have seen three terms called convergent sequence, and if a sequence is convergent then we have something called limit, and if in case a sequence is not convergent we call it as a divergent sequence, right? So now let us do the formal definition. See, abhi we have discussed that a sequence is said to be convergent if after a point of time the terms were quite close to a number, right? So the example which we considered was 1 by n type. So it was the values were 1, 1 by 2, 1 by 3, 1 by 4, 5, 6 and so on so forth. So after a point of time, मतलब after some n, पहले था हमारे पास 1, 1 by 2, 1 by 3, 1 by 4. Let's say you have traveled till 1 by 1000. Then you have traveled till 1 upon 1 lakh, right? And so on. So whenever your n is getting larger and larger, your terms are getting smaller to 0. Means after a point of time, your terms are going very close to 0. So that's how you'll define the convergence of a sequence in general as well. So a sequence is said to be convergent. Let's say you have a sequence xn. You have a sequence is said to be convergent. अब वो convergent है, then there'll be a point around which the cluster will be formed, जिसको we called the limit. So we'll do in the sense that a sequence xn is said to converge to a point x if the terms xn and x are very close to each other. This is not a formal definition. Again, I'm saying formal definition will do, but let us now plot it. So xn and x are very close after some n, right? After a point of time means after crossing some value for n. So these terms are getting closer and closer to each other after some n, right? So how do we define something which is very close to, like the term which is very close to zero, or the terms are getting closer in mathematical sense? We use some terminology called epsilon greater than zero type. What about this epsilon greater than zero? We have that whenever we want to convey that something is very minute, we will try to make it less than every positive number. That is, if I want to say that a number, let's say a, is very minute, so what I'll try to say that it is less than every possible number which is positive. Yani, we are trying to say that a number a which is positive is very minute. Matlab the value for a is, this is 0. The value of a is very minute, means a is less than any other possible positive number which you can think of. So a would be less than epsilon. So what do we do in general? We take epsilon to be an arbitrary number. You know the meaning of the word arbitrary, right? So we take epsilon greater than 0 to be any arbitrary number, and we say that this number a is very close to 0, or the number a is very close to 0 is written like this: a tends to 0 if a can be made less than any number which you can think of, like epsilon right here. And if epsilon is any number, we can take, we want to say that a is very close to 0, so eventually a will be equal to 0. This is something different, right? So what we want to convey is like, now coming to the definition of convergence of a sequence, you say that a sequence xn is converging to a point x if for every epsilon greater than 0. So we saw that the distance between xn and x, the distance between xn and x is getting very minute. The distance between these two things is given by the difference ka mod. So the distance between xn and x means xn minus x ka mod will be less than epsilon after a point of time. Matlab after some natural number. So for every epsilon greater than 0, we can find a natural number, let's say k, such that the distance becomes very minute for every n after that k, right? So what do we have? Let's say for n equal to 1, again let us consider the same example, 1 by n. For n equal to 1, you have your answer as, for n equal to 1, your answer was 1. For n equal to 2, your answer was half. For n equal to 3, your answer was here. For n equal to 4, answer was somewhere here. And when n increases, the answers are like very close to 0. So you have the distance between xn and x is very minute as n crosses a limit. So that's how you are saying that a sequence xn converges to a point x if for every epsilon greater than 0, you can find some k such that after that k, the distance between xn and the point x, right, in case it is 0, xn's are the terms of the sequence. So the distance between the term of the sequence and the number x, which is 0 in our case, is very minute after that particular k. So that's how we define a convergent sequence. And whatever number is there to which the sequence is converging is called the limit. So limit of the sequence xn is nothing but that particular number x to which the sequence is converging, and we denote it by limit xn, which is nothing but x, right? So do you have any doubt anymore for this?
No, ma'am.
So this is clear, right? That is, we say that a sequence is converging to a point x if for every epsilon greater than 0, we can locate a natural number such that the distance between xn minus, that is the distance between xn and x, and the distance which is given by xn minus x ka mod is less than that epsilon for every n greater than equal to this k, right? And we call this x by the limit of the sequence xn, denoted by lim xn, right? So whenever you are able to find such a number for which this thing happens, then we call that the sequence is convergent. The sequence xn is convergent in such a case. And if in case sequence xn is not convergent, we call it as divergent. Right? Got this thing? Okay then. So let us consider a few examples now. First of all, yes, we have the same example 1 by n. So as of now, we have seen that the cluster will be formed around the point 0. Matlab, limit of 1 by n is going to be 0. Just that we have to show it using the definition. So let me quote the definition right now for the time being. That the sequence xn is said to be convergent or it's said to converge to x if for epsilon greater than 0 there exists some natural number such that xn minus x is less than that epsilon for every n greater than equal to this k, right? So for if you change your epsilon, then your k will change, right? Because जैसे ऊपर we have considered, if your k was here, means your epsilon was this much agar, means you have taken this distance, you could see that your k was here. If epsilon drops, if you'll reduce the reduce the magnitude for epsilon, you have k to be here. Means when you'll change your epsilon, k is going to be changed. So your k basically depends upon epsilon. So we'll write it as k epsilon, right? So you want to show that this sequence 1 by n is converging to the point 0, means you'll have to show that for every epsilon greater than 0, you can find some natural number such that the distance between the xn, which is 1 by n in our case, we'll write it, minus x, which is 0, would be less than epsilon for every n greater than equal to that particular number k, right? So how will we do it? Let us start to consider this thing, mod of xn minus x. Right now, what is xn? 1 by n. What is 0? Sorry, what is x? It's 0. So have this quantity as 1 by n. So this quantity you want that it should be less than epsilon, and this should be true for every n greater than equal to some k. So this quantity will be less than epsilon if what will happen? If n is greater than 1 upon epsilon. Means you are able to find a natural number such that n greater than that natural number implies that 1 by n would be less than epsilon. So what that natural number will be? Have a look. If this is one, if you want that n should be greater than 1 by epsilon, let's say this is 1 by epsilon somewhere. So you can find a natural number which is just after 1 by epsilon. So let's say that natural number is k. So after this natural number, means for n being greater than equal to k, you have that n is greater than 1 by epsilon, which will imply that 1 upon n is less than epsilon, which will imply that this quantity is less than epsilon, means 1 by n converges to 0, and that's why limit of 1 by n is equal to 0, right? So you're able to find some natural number which depends upon epsilon, of course. If 1 by epsilon यहाँ हो जाए, then you'll have your k to be somewhere here. If 1 by epsilon is here, then you'll take your k to be the natural number which comes up next. So as epsilon will change, your k will change. But at least you are sure that you are able to find some natural number k such that for n being greater than equal to k, your n is also greater than 1 by epsilon, and hence 1 by n is less than this epsilon, and hence you can say that this quantity is less than epsilon. And if epsilon keeps on changing, k keeps on changing, that's fine. Means if epsilon can be, because epsilon could be any positive number, so this relation 1 by n is less than epsilon for n being greater than equal to k is also possible for every possible number epsilon greater than 0. So for every epsilon greater than 0, we could find a natural number k, which was precisely the natural number which was greater than 1 by epsilon, such that if n is greater than that number, you have that n is greater than 1 by epsilon, which implies 1 by n is less than epsilon, which implies 1 by n minus 0 is less than epsilon, and hence limit of 1 by n is nothing but 0. Right? Got this thing now? So that's how you'll evaluate the limit of a sequence. Or that's how you'll show that the limit of a sequence is some number whichever we have taken into the possible case. Right?
Ma'am, can you give an example?
For
Ma'am, for the same concept.
see, you have an example 1 by n, you can we'll consider one more example then. 1 by n example is clear, right?
Yes, ma'am.
So okay, so let us consider one more example for this. Let's say you have 3n plus 5 upon n plus 2 type of a thing. Let's say that is you want to find the limit of this thing. So how will you find the limit of this thing? I'll tell you, but as of now I'm saying that the limit is going to be 3. You want to really ensure whether the limit is 3 or not. Means you want to ensure if this is your xn and the limit is denoted by x generally. So you really want to ensure that distance between xn and x is less than epsilon for every n greater than equal to some k. So means you want to ensure that you can find some k for every possible epsilon you can think for. Right? This is what you have to do whenever you want to show that xn converges to x. Right? So we'll start with let epsilon being greater than 0 be arbitrary number. So what we'll do, start considering, your motive is to definitely find some natural number such that for that particular epsilon we find some natural number k such that for n greater than equal to that particular number k we have that this quantity should be true, right? So we'll try कि ये quantity किस किस situation में true होगी. So let us consider this quantity first, xn minus x, which is nothing but 3n plus 5 upon n plus 2 minus 3 kind of a thing, which is nothing but 3n plus 5 minus 3n minus 6 upon n plus 2. Means you can say that this is 1 upon n plus 2, right? And this will be less than epsilon if n plus 2 is greater than 1 by epsilon, or if n would be greater than 1 by epsilon minus 2, right? So you're able to find some natural number. Let's say agar 1 by epsilon minus 2 was somewhere here, so you can always spot a natural number for which if n is greater than equal to that number, n is automatically greater than 1 by epsilon minus 2. Means if n is greater than equal to that particular number k which we have spotted, which is further greater than 1 by epsilon minus 2, You have that n plus 2 is greater than 1 by epsilon. You have 1 upon n plus 2 is less than epsilon. Means you have that the difference, which was this one. Can you see it? Now, I think it should be visible right now, all the things which are collective. So, for this particular situation, that is 1 by n plus 2 less than epsilon, you have that this difference is less than epsilon. So, for any epsilon, for any other epsilon, if we have any other epsilon, then we can see that for that particular epsilon, we are always able to find some k. So this is the purpose कि we should be able to really find a k such that after that point of time, the distance between xn's and the x, yeah, in our case, xn is 3n plus 5 upon n plus 2 and x is 3. So the difference between these two things, the distance between these two things is very minute. Means if the distance is very minute, means they are forming a cluster around this number 3. And that's how you'll reach to the final answer that your limit is going to be limit of what? 3n plus 5 upon n plus 2 type of a sequence is nothing but 3. Right? Was there a doubt somewhere?
So, ma'am, we have to represent this like this only. Like we have solved it right now.
No, I'll tell you the attemptation for this one, but firstly you should be clear with the concept. If the concept is clear, I'll write it well.
Okay, ma'am. Yes. And ma'am, one more doubt. Can there be two limit points for one sequence?
See, limit, there's a difference between a limit point and a limit. So right now we are talking about the limit, but and the limit has to be unique. Limit points can be multiple, but we are not considering limit points as of now. Just that you have to make sure that limit is something which is unique. And we'll show
Okay.
that the limit is also, we may be doing a theorem stating that limit is unique. We'll be proving it as well. But right now you're not really concerned about the limit point. There's a difference between limit point and the limit. All you need right now is the limit which is unique. Okay. So let us consider how to attempt this thing. So you're given that you want to show limit 3n plus 5 upon n plus 2 is 3. The example which we have just taken. Right. So how will you solve it? Of course, let us just keep it in the rough section. What do you want to show? That for every epsilon greater than 0, you can find a natural number such that the distance between these two things, xn minus x in general hota hai. Right now, the distance between 3n plus 5 upon n plus 2 minus 3 would be less than epsilon for every n greater than equal to some k which we'll find. Right? So let us write how to attempt this. You'll write let epsilon greater than 0 be arbitrary, because for any epsilon we want to show this, let us take a general random number which we generally call by arbitrary number in mathematical sense. So let epsilon greater than 0 be arbitrary, and let's say xn is equal to 3n plus 5 upon n plus 2 and x is equal to 3. So consider this, which is 3n plus 5 upon n plus 2 minus 3, which is and which is precisely 1 upon n plus 2. Now, there's one more thing, like pehle we did that it is less than epsilon if 1 upon n plus 2 is less than epsilon if n plus 2 is greater than 1 by epsilon. But there is one more thing which you can do. See, n plus 2 is greater than n or not, first of all. It is greater than n. So you can say that 1 upon n plus 2 is less than 1 upon n. So this is less than 1 upon n. This is less than epsilon if n is greater than 1 by epsilon. So what you'll do, you'll assume Let k be a natural number. You can always find a natural number after some real number. You know it. Because for any real number, you have a natural number with you which is lying after that or which is greater than that. So let k be a natural number such that k is greater than that number which we have right here, 1 by epsilon or whatever the case will be according to the situation. Right now you have 1 by epsilon. So for n being greater than equal to k, we have n is greater than equal to k, which is further greater than 1 by epsilon, which implies 1 upon n is less than epsilon. And because 1 upon n is less than epsilon, you can mark it as equation number, let's say 1 here. So using equation number 1, what do you have? You have that this difference, this one, is less than epsilon for every n greater than equal to that particular k which we have checked for, which we have spotted right now. So equation 1 implies, yeah, inequality 1 implies that, yeah, it will give that the difference 3n plus 2 upon n plus 5 minus n plus n plus 2 था ना यहाँ पर जो भी था 3n plus 5 upon n plus 2 minus 3 is less than epsilon for every n greater than equal to this particular k which we have checked for, right? So you can right now say therefore limit of what 3n plus 5 whatever was given to us is nothing but this particular number 3, which is 3. So that's how you'll solve this question, right? That's how you'll attempt this question now. So you have that the limit is of this sort. Okay? Is there any doubt so far? Okay then. So next up we have few more expressions of this thing. Okay, so how can, in what all manner we can also write these things? You have that mod of xn minus x should be less than epsilon, means it is same as saying xn minus x is less than epsilon and greater than minus epsilon, yes or no? We have dealt it before. So xn minus x is less than epsilon, greater than minus epsilon. It can also be written as xn is less than x plus epsilon and is greater than x minus epsilon, right? So these three are the equivalent forms of each other. So we can say that the sequence xn is converging to x if for every epsilon greater than 0 there exists some natural number k natural number such that st stands for such that xn minus this x is less than epsilon for every n greater than equal to k, or you can even write it like xn minus x is between epsilon and minus epsilon for every n greater than equal to k, because we have just seen we can write this inequality as this as well, or we can even write xn lies between x plus epsilon and x minus epsilon for every n greater than equal to k. So if we write in any of these three manners, these are one and the same. So these are equivalent conditions for xn being convergent to the point x. That is, xn converges to the point x if for every epsilon greater than 0, there exists some natural number k such that either of these three conditions hold for n greater than equal to that particular number k, right? So that's how you can find an equivalent form or equivalent expressions for a sequence being convergent. Remember, epsilon has to be an arbitrary number. Okay, so next up we have that this convergent sequence is going to be bounded. See, we know the sequence which is convergent, we know that a sequence is bounded, but how they are actually related is the next theorem. Is there anything? So we have that a convergent sequence is bounded. Means we want to show कि if in case we have a sequence xn which is convergent, we would like to show that the sequence xn is bounded, right? So let us see how it happens. But before that, let us consider one more thing, like the definition of the sequence being bounded once again. So the definition was a sequence xn is said to be bounded if BDD stands for bounded. If I write BDD or if I write the full word bounded, they both mean the same, right? So a sequence xn is said to be bounded if you are able to locate m and m, which were finite as we discussed, such that xn is between m and this particular number m. So for such numbers, we could see that if if we have such numbers m and m such that xn is between this particular small m and capital M for every n in n, then we call the sequence to be bounded, right? What if we write it like this? If we are able to find a positive number n, positive number m, such that mod of xn is less than equal to that m, can we say the sequence is bounded? Yes, because this is same as saying xn is between m and minus m. So अगर आपके पास एक lower bound मिल गया and एक upper bound भी मिल गया, then you can say that the sequence xn is also bounded. This should be true for every n in n. For every n in n. If this quantity, if this situation, if this inequality holds for every natural number, then we can also say that sequence is bounded, yes or no? So in such a case, the sequence xn is bounded, right? So we can use this as a definition as well. I'm quoting it formally. A sequence xn is said to be bounded if again you're looking for a number. Pehle you were looking for two numbers such that xn would be greater than that and less than the other one. Right now you're looking for just one number m greater than 0 such that the modulus of xn will be less than equal to this m for every n in n. So a sequence is said to be bounded if this modulus of the sequence xn is less than equal to some positive number m. So this can also be used as a definition for a sequence to be bounded, which we'll use to show the proof right now. Means we would like to show that a sequence is convergent. This implies the sequence will be bounded as well. So let's see how. Again, quoting the theorem once again, a convergent sequence is bounded. So let us start. Let xn be a convergent sequence. So if xn is a convergent sequence, of course, we have its limit. And let limit क्या है? Limit of xn is equal to, let's say, x. Right? If xn is a convergent sequence and let's say the limit of xn is equal to x, what do we have? Again, apply the definition. For epsilon greater than 0, there would be a sum k such that what will happen? The distance between xn and x is very minute, means less than epsilon for every n greater than equal to this k. Right? This is the definition. And further, see, we would have that xn is between x plus epsilon and is between x minus epsilon for every n greater than equal to k. Now, if this thing is true for every positive number, what if we take it to be 1? This will be true for epsilon equal to 1 in particular as well, because xn converges to x. It was true for every positive number. So let's say in particular for epsilon equal to 1, we are able to find some natural number k such that for epsilon equal to 1, which is positive, we find, yeah, there exists k in the natural numbers such that mod of xn minus x is less than 1 for every n greater than equal to that k, right? Ab, you know that we want to show that the sequence xn is bounded. Matlab we are looking for a number m such that modulus of xn should be less than that particular number m, right? So let us consider this should be true for every n in n. So we'll start considering with
मैम
hmm,
मैम थोड़ा स्लो चलिए, आप बहुत स्पीड से बता रहे हो, आप थोड़ा सा
okay, okay,
थ्योरम के बाद समझ में नहीं आया.
okay, let us consider it again, not a problem.
यस मैम, मैम यही से समझ नहीं आया मुझे थोड़ा सा
Okay, okay,
इस थ्योरम से.
okay. You know the definition for bounded, the second definition which we have considered?
यस मैम.
Okay, so theorem says कि a convergent sequence is bounded, means you have a sequence which is convergent and you would like to show कि वो bounded होगा, right? So let us start considering कि एक sequence था xn which was convergent. अगर वो convergent है तो उसका कुछ limit होगा, let's say the limit was x, right? And if it is convergent, the limit is x, we'll just apply the definition that for every epsilon greater than 0, we can find a number, natural number, which is given by k, such that for that particular number, after that particular number k, the distance xn minus x would be less than epsilon. अब ये चीज was true for every epsilon positive. So in particular, अगर हम epsilon को 1 ले लें, then do we have a problem? So we take epsilon to be equal to 1. So for this epsilon equal to 1, we can find some natural number such that the distance between xn and x is going to be less than 1. Simple, right? This much is clear, right?
यस मैम.
Okay. So you want to show now, जो sequence था आपके पास which was convergent, you want to show that the sequence is also bounded. Means you're trying to look for a bound over that. You're trying to look for a number m which is such that modulus of xn is less than that particular number m, and this should be true for every n and n, right? So let us consider कि how xn will look like. So xn के साथ start किया and you have something in picture. Xn minus x kind of some structure was there. So let us bring here the xn minus x kind of a thing. We can write this as xn minus x plus x, and this is less than equal to, use the triangles inequality, right? And this quantity, this one xn minus x, is further less than 1, and this plus x kept intact, but this was true for what? For every n greater than equal to that k जो हमने find किया था, right? So you have seen कि xn's are less than 1 plus mod of x, but after a point of time, after some k. We don't know before k वो कैसा deal करता है. All we need is to check for a bound over the terms of xn, over the terms of sequence xn, and the bound should be there for every possible number n, right? So जो bound है हमारे पास xn के ऊपर अभी तक मिला है 1 plus mod of x, which is because of n being greater than equal to k. मतलब if you have this is your x1, this is x2, this is x3, and let's say this is xk plus 1. So you have seen that after kth term, all the values were bounded by 1 plus mod of x, but अभी हमारे पास इसके बारे में information नहीं है, right? So what we'll do, we'll try to look for the maximum of these.
मैम इसका मतलब हमने अपना एक बाउंड ढूंढ लिया है, मतलब
एक बाउंड ढूंढ
जो
लिया है।
अपर बाउंड है।
देखो, अपर बाउंड यहाँ पर विल नॉट बी जस्ट दिस पॉसिबिलिटी। सी, अपर बाउंड की बात नहीं कर रहे हैं हम लोग यहाँ पर, हम लोग चेक कर रहे हैं एक ऐसा बाउंड दैट शुड बी देयर फॉर एवरी पॉसिबल नंबर। देखो, हमें चाहिए एक्स एन शुड बी बाउंडेड बाय एन अपर बाउंड एंड दिस शुड बी ट्रू फॉर एवरी एन इन एन। मतलब फॉर n equal to 1, x1 should be less than that number, n equal to 2, x2 should be less than that number, and so on. But right now what do you have? यहाँ पर situation देखो, you have xn is less than equal to 1 plus mod x for n being greater than equal to k. मतलब you have xk is less than equal to 1 plus mod x, xk plus 1 is less than equal to 1 plus mod x. हो सकता है ना कि x1 इससे आगे निकल जाए, x2 उसके भी आगे निकल जाए, बट एटलीस्ट आपको ये पता है कि एक्स के, k+1, k+2, k+3 ये सारे बाउंड हो गए हैं विद 1 प्लस मॉड एक्स। जस्ट दैट आपको इसके बारे में कुछ इन्फॉर्मेशन नहीं है कि दिस विल बी लेस देन इक्वल टू समथिंग और नॉट। यू डोंट नो x2 इज लेस देन इक्वल टू समथिंग और नॉट। यू डोंट नो कि टिल xk-1 विल बी हैविंग समथिंग लेस देन इक्वल टू समथिंग और नॉट। जस्ट दैट k onwards तो हमारे पास सारे are less than equal to 1 plus mod x. But to show a sequence to be bounded, we want कि हर number should be bounded by just one particular number. एक bound मिल जाए हमारे पास हर possibility के लिए, right? बात समझ में आई? I'm repeating. See, again, have a look. You want to show that your xn should be less than equal to some number for every n in the natural numbers, right? So far you have seen कि xn will be less than equal to 1 plus mod x, but for what sort of natural numbers? For n being greater than equal to k. हमें चाहिए इन एक बाउंड आ जाए सारे नंबर्स के लिए, सारे एंस के लिए, बट अभी बाउंड मिला है कुछ सिलेक्टेड एंस के लिए। मतलब k के लिए मिल चुका है, k+1 के लिए मिल चुका है, k+2 एंड ऑनवर्ड्स के लिए मिल चुका है, बट यू डोंट नो कि हाउ xn विल बिहेव फॉर n बीइंग इक्वल टू 1, 2, 3 एंड k-1, राइट? बाउंड किस पे चाहिए? सारे एंड्स के लिए। मतलब x1 शुड बी लेस देन इक्वल टू m, x2 शुड बी लेस देन इक्वल टू m, x3 का मॉड शुड बी लेस देन इक्वल टू m एंड सो ऑन। हमें चाहिए कि वो जो m मिले वो सभी एक्सेंस के लिए काम करे। बट अभी जो आपके पास जो बाउंड आने लगा है वो किसके लिए है? फॉर k+1, k+2 एंड सो ऑन, right? You're not aware of the fact कि you're not aware of the situation कि x1, x2, x3 इन पर बाउंड क्या होगा टिल xk-1। k onwards आपके पास बाउंड आ चुका है, k तक बाउंड के बारे में हमें पता नहीं। As soon as we are able to find the bound for these k's as well, for first few k-1 numbers as well, and for the rest of them, we are able to ensure कि xn will be bounded. This is the story. Is it clear now?
यस मैम।
So all you need is to find the bound for the first k-1 terms, right? So what do we have? You have that xn is less than equal to 1 plus mod of x for every n greater than equal to k. ठीक है? अब how will we find the bound for rest of the terms? You know that the rest of the terms are going to be bounded by themselves. कैसे? देखो, x1 will be bounded by mod of x1 of course, x2 will be bounded by mod of x2 of course, होगा। You can see ना, like अगर x1 होता let's say -1 तो उसका बाउंड हो जाता 1, x2 होता -2 उसका बाउंड हो जाता 2, right? Can you imagine the example now? And similarly xk-1 जो है will be bounded by xk-1 as well. So जो ये finitely many terms मिली हमें, इनमें से हम मैक्सिमम चूज कर लेते हैं। Let's say m is the maximum of all these numbers x1, mod x2 and mod xk-1 and 1 plus mod of x. So you can see now जो xn's होंगे If n is equal to 1, it is less than equal to m, yes, because वो यहाँ से satisfy हो जाएगा. If n is equal to 2, it is less than equal to m because maximum जो भी है इसका x2 is less than equal to mod of x2, and m was the maximum of all. मतलब mod of x2 will be less than equal to m for sure, no? Because m was the maximum of all the values taken. अगर वो खुद maximum अगर खुद mod x2 होता तो m would have been mod of x2 itself. लेकिन इसमें से suppose maximum था x5 वाला term, ठीक है? So x2 mod of x2 is less than equal to mod of x5 because maximum x5 था. So this will be less than equal to m. Yes or no?
Yes, ma'am.
So each of the terms, each of these terms xn's will be less than equal to m. क्यों? देखो फर्स्ट n तो अपने से लेस देन इक्वल टू है ही, तो वो उन सब में से जो भी हमने मैक्सिमम चूज किया होता उससे भी लेस होंगी. एंड k ऑनवर्ड्स, k ऑनवर्ड्स सारी इससे लेस थी, तो उस ओवरऑल मैक्सिमम से भी तो लेसर देन दैट होंगी कि नहीं. So each of these xn's are less than equal to this m chosen, which was maximum of these k terms, k many terms. Is it okay now with everyone?
Yes, ma'am.
So we have
Yes.
that a sequence which was bounded, a sequence which was convergent is also bounded, right? I'm repeating the proof. You can visit it again. You have that a sequence which was convergent. You wanted to show that it is bounded as well. So let's say xn is a convergent sequence. अगर sequence convergent है तो उसकी कोई limit भी होगी. Let's say limit was x. And if we have a convergent sequence with the limit x, matlab we can apply the definition right now that for every epsilon greater than 0, we are able to find, या फिर simply there exists a natural number k such that mod of xn minus x means the distance between xn minus x is less than epsilon for every n greater than equal to k. हम n greater than equal to k क्यों कर रहे हैं? Because after a point of time xn जो है वो x के close हो जा रहे हैं. जरूरी नहीं है they should be really close to the number x starting में, but after a point of time, after some particular number k, for every n greater than equal to that k, xn's are getting closer to x, means the distance between xn and x is less than epsilon, means the distance is very minute. epsilon छोटा करोगे distance और कम हो जाएगा, epsilon और छोटा करोगे distance और कम होते चले जाएगा. मतलब for any epsilon, for any other positive number, for any minor या small positive number we take, we are always able to find a natural number k such that the distance is getting smaller and smaller and smaller, right? The distance is getting smaller than that small number means the distance is even smaller, right? So if it is true for every positive number, let us take it to be true for the positive number 1. That is epsilon equal to 1 के लिए we have that there would exist a number k such that xn minus x will be less than 1. यानी अब देखो, we wanted that a sequence to be bounded, means we were looking for a number m such that mod of xn would be less than that m, and this should be true for every n in n, right? So let us start considering with what xn's are. xn के ऊपर बाउंड चाहिए, but right now you cannot straight away say कि xn is less than equal to something, but we have a relation with xn and x. So let us try to make that picture here. That is xn can be written as xn minus x plus x using the triangles inequality. You know the triangles inequality, right? A plus b less than equal to mod a plus mod b kind of a thing. So ये आपका a का रोल प्ले कर रहा है और ये b. So if you have xn minus x plus x ka mod, this is less than equal to mod of xn minus x plus mod of x. So using this equation number 1, you can see that xn minus x is less than 1 plus x, but this was true for n being greater than equal to k. Yani n being greater than equal to k. So what you have got, I'm writing it again. So jab tak you got this thing that this is 1 plus mod of x for n being greater than equal to k means xk is less than equal to 1 plus mod x. Xk plus 1 is less than equal to 1 plus mod x. Xk plus 2 is less than equal to 1 plus mod x, and so on so forth onwards. But to show that your sequence is bounded, you wanted कि आपको हर टर्म के ऊपर mod of xn would be less than equal to some number for every n in n. अभी जो सिचुएशन है हमारे पास दैट इज फॉर n इक्वल टू k प्लस वन k प्लस टू k प्लस थ्री एंड सो ऑन. बाकी के टर्म्स के लिए हमें कुछ नहीं पता. सो बाकी के टर्म्स के लिए विल ट्राई टू फाइंड एक ऐसा नंबर जो कि सारी टर्म्स पे फिट हो जाए. सो लेट अस टेक बाकी कौन सी टर्म्स बची हैं आपके पास. x1 के ऊपर बाउंड नहीं पता, x2 के ऊपर बाउंड नहीं पता एज सच, एंड अप टिल xk माइनस वन के ऊपर बाउंड नहीं पता, बट बाकी के लिए बाउंड इज 1 प्लस मॉड ऑफ x. इट इज नोन टू यू. नाउ हैव अ लुक. ये सारी आर फाइनाइटली कितनी टर्म्स हो गई आपके पास. 1 2 3 अप टिल k माइनस वन टर्म्स है. तो इन k माइनस वन टर्म्स में से आई कैन पिक अ मॉड, आई कैन पिक अ मैक्सिमम ऑफ ऑल दीज. So let's say m is the maximum of these moduli, all the modulus x1, x2, x3 up till xk minus 1 and 1 plus mod x as well. हमने क्या किया, उन k माइनस वन टर्म्स के मॉडुलस को कलेक्ट किया और एक और जो अपर बाउंड मिला था हमने उस उन सब में से मैक्सिमम जो भी क्वांटिटी है उसको m बुला दिया. राइट. सो यू कैन सी कि एक्स एन्स जो है वो लेस देन इक्वल टू एम तो है फॉर एवरी एन ग्रेटर देन इक्वल टू के, बिकॉज वो इस टर्म से छोटे हैं. तो उस इन बाकी टर्म्स के मैक्सिमम से भी तो छोटे ही होंगे ना, बिकॉज m इज द मैक्सिमम ऑफ ऑल दीज. मतलब m इज ग्रेटर देन ईच ऑफ द टर्म्स, मतलब m इज ग्रेटर देन इक्वल टू दिस टर्म एज वेल. सो n ग्रेटर देन इक्वल टू k के लिए आपके पास था xn इज लेस देन इक्वल टू 1 प्लस मॉड x which is further less than equal to m. So xn's are less than equal to m for n being greater than equal to k. This is sorted, right? And for n is equal to 1 2 3 and so on, xn क्या था, xn अपने आप से तो छोटा हो गई, which is further less than equal to m, right? Up till k minus 1 we are considering. So for n equal to 1 2 3 up till k minus 1, xn का mod is definitely less than equal to उसके खुद का mod, which is less than equal to m because m was the maximum of these as well, right? So xn k onwards के लिए भी m से छोटा है, k तक के लिए भी m से छोटा है. So overall what do you have, xn सभी के लिए m से छोटा है, and this is true for every n in n, and therefore you can say that the sequence xn is now bounded. Okay, is it okay now? So you have
Yes.
seen that your xn which was given convergent is now bounded. CGT stands for convergent. I hope you are not confused anywhere whenever I'm using some notations like these. And BDD stands for bounded, right? So you have seen that a sequence which is convergent is also bounded. Then I have a question. Whether if you have a bounded sequence, then can you say that is convergent? Is the question. If you have a bounded sequence, हमें पता है convergent है तो bounded होगा, लेकिन अगर bounded है तो क्या convergent होगा? What is your guess? Yes or no? The answer will be no. Because let us consider an example. हम बोल रहे हैं कि sequence is bounded बट ज़रूरी नहीं है कि वो कन्वर्जेंट हो। दिस सीक्वेंस इज बाउंडेड, राइट? इसका बाउंड क्या था हमारे पास? 1 and -1। अगर हम पॉजिटिव सेंस में लेने जाएं तो द बाउंड वाज 1, राइट? दिस सीक्वेंस इज नॉट कन्वर्जेंट। क्यों? द टर्म्स वर जंपिंग बिटवीन -1 and 1 ऑल्टरनेटिवली। सो हमारे पास कभी भी ऐसा सिचुएशन नहीं आया था दैट आफ्टर अ पॉइंट ऑफ टाइम सारी टर्म्स एक ही तरफ हो जाएं। हमेशा ऐसा हो रहा था ना, -1 1 -1 1 -1 1 -1 1। मतलब कभी भी ऐसी सिचुएशन नहीं आई सच दैट आफ्टर अ पॉइंट ऑफ टाइम सारी आर ईदर गोइंग टू 1 और all the terms were either going to or the terms were going to -1. So they were always jumping alternatively between -1 and 1, but they were not converging to some number. So this is one of the sequences which is bounded but not convergent. Remember, not convergent. Right? Got this thing?
Yes, ma'am.
All right. So this is one of the examples which is like which are very important. That is, you have the sequence which is bounded but not convergent, but you have seen that a sequence which is convergent is definitely bounded. And one more thing which you are discussing, a sort of a theorem kind of a thing, that the limit of a sequence is unique. So let us try to prove this कि अगर हमारे पास कोई सीक्वेंस है जिसकी कुछ लिमिट है, तो लिमिट हैज़ टू बी यूनिक। मतलब सीक्वेंस अगर है xn, सपोज वो x1 को कन्वर्ज करती थी एंड सपोज वो x2 को भी कन्वर्ज करती थी, देन विल शो कि ये दोनों आर वन एंड द सेम नंबर्स, दे आर नॉट डिफरेंट एट ऑल, राइट? सो let us now try to solve for limit of a sequence is unique. So let us assume for the time being, let x1 भी एक लिमिट है। x1 मत लो, x ले लो और x dash, क्योंकि x1 और x2 are more or less the terms of the sequence, right? So let's say x and x dash are limits of the sequence xn. Yani, again, let us apply the definition. For epsilon greater than 0, there exists kya? Some number, let's say k1 for x and k2 for x2 will write. So k1 in the natural number such that xn minus x ka mod is less than epsilon for every n greater than equal to this k1. And because xn is also converging to, see what we are doing, because xn converges to the point x for epsilon greater than 0, we can find a natural number k1 such that the distance between xn and x is less than epsilon for every greater than equal to for every n greater than equal to k1, right? Because यही काम हो रहा है with xn की limit as x dash, we can say again for epsilon greater than 0, there exists some other number k2 such that xn minus x dash is less than epsilon for every n greater than equal to k2। ये दोनों चीजें ठीक है? ये बात समझ में आई? What do we have? We assumed कि x और x dash दोनों ही लिमिट्स हैं xn की। अब अगर लिमिट xn is x, मतलब for every epsilon we can find a natural number such that the distance between them is less than epsilon, and अगर distance limit is x dash, again for epsilon greater than 0 we can find another natural number so the distance is less than epsilon, right? The whole story is repeated again and again, the definition is applied, nothing else, right? So
Yes, ma'am.
we want to show eventually कि x और x dash are one and the same, मतलब we want to show x minus x dash should be 0, right? So let us consider, जो भी आपको चीज शो करनी है उसको पिक करो और उसके साथ सॉल्व करना शुरू करो। So let us consider x minus x dash का mod, क्योंकि सारा काम we have been doing in mod. So let us consider x minus x dash का mod, and how can we relate with x n's is your question right now. So xn's are there in picture. How? x minus xn plus xn minus x अगर हम करें तो कोई दिक्कत? अब we have that the modulus is separated over these, and the best way out to separate a modulus is by what do we call this inequality? होगा? By using the triangles inequality, you have this, and this quantity is less than epsilon for every n greater than equal to k1 from equation number 1. You have seen. Can you see it now? Together. And also this quantity is less than epsilon for every n greater than equal to k2 from equation number 1. This is from equation number 2. Right? So overall we have that this quantity would be less than 2 epsilon. लेकिन अगर हम यहाँ पर for epsilon greater than 0 हम बोलते it is less than epsilon by 2, तो कोई दिक्कत? क्योंकि if it is true for every positive number, it is true for the half of that positive number as well. If it is true for every positive number, it is true for half of the positive number as well. So this is less than epsilon by 2, this is less than epsilon by 2. Overall epsilon means you have that x minus x dash is less than epsilon for every n greater than equal to k1 bhi, and for every n greater than equal to k2 as well. Right? Have you seen it here? So you have that the difference between x and x dash. अब देखो x was a fixed number, x dash was also a fixed number. कोई नहीं दो fixed number के बीच में the difference is very minute. देखो अब n के ऊपर तो ये depend कर नहीं रहा. X was a fixed number, x dash was a fixed number. So no matter whatever n is, this quantity is less than every positive number which you can think of. The only fixed quantity which is less than every positive number is the only fixed quantity positive non negative fixed quantity, क्योंकि देखो mod क्या है, एक non negative term होगी, negative तो ये हो नहीं सकता. So only negative quantity which is less than every positive number, which is less than half, less than 1 by 3, 1 by 4, 1 by 5. What is that positive quantity? What is that non negative quantity? Isn't it zero? होना पड़ेगा इसको zero, क्योंकि दिस इज ट्रू फॉर एवरी एप्सिलॉन. एप्सिलॉन चाहे कितना ही छोटा कर दोगे, आंसर स्टिल x और x डैश के बीच में जो डिफरेंस है वो तब भी एप्सिलॉन से छोटा है. एप्सिलॉन अगर 1 होता, the difference was less than 1. Epsilon half होता, the difference was less than half. Epsilon 1 by 3 होता, the difference was less than 1 by 3. So epsilon कितना भी minor कर दो, the difference is less than that. So what that difference can be, एक ऐसा fixed number दो मुझे such that वो हर एक number, हर possible positive number से छोटा हो. That fixed number has to be zero, yes or no?
Yes, ma'am.
Yes, ma'am.
So what do you have? Your difference x minus x dash is itself 0, मतलब x is itself x dash. So अगर दो limits भी थी, तो वो दो limits have to be the same, they cannot be different, and hence the limit is unique, right? So that's how you say that the limit is going to be unique. Is it okay?
Yes, ma'am.
So you
Yes, ma'am.
have shown that the limit is a unique number. So today we have done the convergence and the limit and a few theorems over which we are talking about the limit being unique or what, and the theorem about the convergence implies boundedness but not the converse key. If in case you have a bounded sequence, then the sequence need not be convergent. And also we have discussed कि if a sequence is there which is convergent, which is not convergent, the sequence is called divergent, right? So the sequence which is not convergent is called divergent, and further we will be having some specific type of some types of divergent sequences which we'll discuss. So let us discuss them right now because this is very simple. Okay, so let us discuss the possibilities for divergent sequences. देखो एक तो तरीका है डाइवर्जेंट का कि द टर्म्स आर एक्सपैंडिंग ओवरऑल, कि टर्म्स जो है वो एक्सपैंड होते चली जा रही हैं, लाइक इन द सेंस द सीक्वेंस n which was nothing but 1, 2, 3, 4 and so on. So we saw that the terms of the sequence are falling far apart of each other every single time. So this is simply a divergent sequence, right? And what do you think कि इसकी terms कहाँ तक जा रही हैं? You have 1, you have 2, you have 3, you have 4 and so on. So the terms are going to infinity, right? So this is a divergent sequence and diverging towards plus infinity. Similarly, this is a divergent sequence diverging towards this diverges towards plus infinity. So this diverges towards
Minus infinity.
absolutely. So this diverges towards minus infinity and hence we have the divergent sequence in this manner. Next, हमने एक और sequence consider किया था minus 1 to the power n. See, the terms were like, again, they were alternating between minus 1, 1, minus 1, minus 1, sorry, minus 1, 1 के बीच में they were alternating all the time, right? So, this is what? They are oscillating but in the finite manner, कि ना तो ये minus 1 के बाहर जा रही है ना ये 1 के बाहर जा रही है. So, it is like jumping between minus 1, 1, minus 1, 1 all the time. ना तो ये कन्वर्ज हो रहा है क्योंकि हमारे पास कोई एक ऐसा पॉइंट नहीं मिल रहा जिसके पास में क्लस्टर फॉर्म हो रहा हो आफ्टर सम पॉइंट ऑफ टाइम. सो कन्वर्जेंट तो ये है नहीं. डाइवर्जेंट है इन व्हाट सेंस? ये ऑसिलेट कर रहा है, लाइक दीज आर जंपिंग बिटवीन दीज टू नंबर्स, ऑसिलेट कर रहा है इन द फाइनाइट सेंस. सो ऐसी सीक्वेंस को वी कॉल एज फाइनाइटली ऑसिलेटिंग डाइवर्जेंट सीक्वेंस, राइट? डाइवर्जेंट है क्योंकि कन्वर्जेंट नहीं है, ऑसिलेट कर रहा है क्योंकि एज वी डिस्कस जंप कर रहा था, और फाइनाइट पॉइंट्स के बीच में जंप कर रहा है, तो यस इट इज फाइनाइटली ऑसिलेटिंग डाइवर्जेंट सीक्वेंस. नेक्स्ट, वन मोर थिंग, व्हाट इफ यू हैव minus 1 to the power n times n? ये कैसा दिखेगा? It'll be minus 1, 2, minus 3, 4, minus 5, 6 and so on. मतलब your answers are like, if this is 0, minus 1, 2, minus 3, 4, minus 5, 6 going beyond. So कैसा बनेगा ये? What can you comment about it? Just ऊपर वाला example देखो और you can comment for the answer what kind of sequence it will be like. पहली बात, convergent है,
No, ma'am.
so divergent is done. Next up, oscillating है, infinity को जा रहा है या माइनस infinity को जा रहा है, पहली चीज. दोनों में से वी आर नॉट रियली श्योर क्योंकि वो हर बार अपने साइंस को भी ऑल्टरनेट कर रहा है, राइट? सो इन्फिनिटी है या माइनस इन्फिनिटी वी कैन नॉट कमेंट क्योंकि वो ऑसिलेटिंग है. सो ऑसिलेटिंग तो है, और फाइनाइट है या इनफाइनाइट ऑसिलेटिंग है, दैट इज व्हाट यू नीड टू जज नाउ. फाइनाइट है या इनफाइनाइट है?
Infinite, I guess.
Infinite.
सो इनफाइनाइटली ऑसिलेटिंग डाइवर्जेंट सीक्वेंस, राइट? क्लियर? नाउ one more example. Let us take it to be like minus 1 to the power n times 1 by n. Huh. So what sort of behavior does this sequence will show? You have this as 0, you have this as 1, this as minus 1. ठीक है? So the first term is, इसकी terms कुछ ऐसा form करेंगी structure. So what sort of structure do you have? minus 1, half, minus 1 by 3, 1 by 4, minus 1 by 5, 1 by 6. कैसा है, कन्वर्ज कर रहा है या डाइवर्ज कर रहा है? यहाँ पर क्लस्टर फॉर्म होने लगा, जीरो के अराउंड बहुत सारी टर्म्स आ जाएंगी. तो यू कैन सी दैट दिस इज कन्वर्जेंट राइट नाउ. एंड किस टाइप का कन्वर्जेंट? ऑसिलेट करने वाला कन्वर्जेंट बिटवीन, अब फाइनाइट तो होगा ही बिकॉज कन्वर्जेंट है तो बाउंडेड होगा, बाउंडेड है तो मतलब इन्फिनिटी तक तो जा नहीं सकता. सो ऑसिलेटिंग कन्वर्जेंट या ऑसिलेटरी कन्वर्जेंट बुला दो इसको. राइट. सो कन्वर्जेंस के टाइम पर भी वी कैन ऑसिलेट, बट ऑफ कोर्स कन्वर्जेंट है और ऑसिलेट कर रहा है तो फाइनाइट तो डेफिनेटली होगा बिकॉज वी हैव सीन कि कन्वर्जेंट है तो बाउंडेड होगा, बाउंडेड है तो ऑफ कोर्स वी कैन नॉट गो टू infinity and hence it has to be finite. So there's a concept which we have just seen by an example that it is oscillating convergent sequence, right? So that's how you have
Yes,
different
ma'am.
names for different types of the sequences. ठीक है. So for these particular with these particular definitions or the terminologies, we are concluding the topic for the day. And if in case you have any doubts, you can discuss